All right. So have that replacement video that I posted for Tuesday's class. I'll kind of summarize kind of where it left off and kind of the next thing we're kind of going to go into. Before we kind of get into material, though, just some things kind of mentioned before we got spring break next week. So what's due at the end of the day tomorrow? I moved it down here, so it's kind of the latest module, but that third pack back assignment. So make sure you're getting on, get that done before spring break, right? Don't have to worry about it over spring break and to get that done. There's no module reading over spring break because once we get back, what's that first week? Our second midterm, okay? So that Tuesday's class will be doing kind of review, going over this practice exam. I'll kind of field the class for questions on it, kind of start with those, do the ones that I think are maybe important. So you've got that practice exam to kind of start studying through. So people have been asking me about old exams, things like that. That's really where these practice exams come from, is it's old exam questions that I'm putting on there because I wrote the second exam, so I know what questions might look pretty representative of that. So that's going to be kind of your number one resource in studying. From there, just like the first one, I would then kind of progress towards looking over old quiz questions, right? You had notes, everything available to you there. Old practice problems. And then if you kind of still want more problems to work through, go through the old in-class questions. I usually go through those with you together. Make sure you can do those on your own, right? Reviewing your notes, reviewing slides is good, but that's kind of the order in which I would do things, right? If you're wanting more practice with questions, you got quite a good bank of questions there from the things that I just mentioned, okay? You will have a Module 9 quiz. I have the due date set to be that Monday after spring break. So I would probably do that before you get too far into spring break and forget about it. So I might try to get it done, before you head home, or, do it today, tomorrow, over the weekend. But you can do it up until that Monday that we return, okay? I also put up an announcement that the CL sessions for this week, there's a couple of the leaders who are traveling already or have other commitments. There won't be any this Sunday, right? So the CL sessions tonight are somewhat limited. So I've got kind of up exactly where they are. I think there's 2 room locations at every time slot instead of 3 tonight. So you'll still have those available if you want to attend those tonight. The Sunday CL sessions will be the Sunday that we'll be returning from spring break. So I think it's at what, the 23rd? Yeah, the 23rd. Same kind of thing. There's, instead of all 3 locations, there's only going to be 2 locations at those time slots that Sunday right before we return from spring break as well. Okay. So that I think should be all the logistical stuff before we jump into material. Any questions for me before we get started here? So I'll also put an announcement up either this afternoon or early tomorrow. I'm kind of finalizing. I've got a room reserved for that Monday that we return, kind of like for my office hours. There'll be a slightly different time than they usually are just because of room reservation. But my office gets a little small, kind of closer to exam time. So I want to make sure I can answer multiple questions at the same time. So I'm going to reserve a room that's somewhat nearby. Valentine, I think I've got Franklin Hall reserved. I still am waiting on the confirmation. But I'll get that information out there as well. Kind of office hours will look a little bit different that week before the exam once we return. Okay. Any other questions for me before we dive into material here? Good. Okay. So I've got kind of this table, right? That we could kind of fill in. I'm going to leave this one for you guys to kind of do additional practice. We'll work through one here together, but from this blank table, you could fill in all the remaining information about the different costs of a firm based off what was reviewed in that video. So we've got some equations that are going to be helpful. Really at the end of the day, what this kind of boils down to is if I want to find the average, I'm going to just take the total of whatever type of cost that is. So total cost, total variable, total fixed, and I'm going to divide it by the quantity I'm producing. Right? I'm taking that total cost and I'm spreading it out on average over 50 units. So my averages are just taking the total of whatever type of cost I'm interested in, variable, fixed, or the total, dividing by quantity. Our total costs, just by definition, are just the sum of our variable and our fixed costs. Okay. So our variable and our fixed, we said fixed are things I can't change in the short run. Variable are things that I can change. Okay? We'll talk a little bit more about the short versus the long run here today. But the idea of variable costs these are things I can hire and fire workers every minute of the day if I really want to. I'm locked into my lease agreement maybe for sometimes more than a year on my production facility or whatever it is. And we then have this idea of marginal cost, which marginal anything is the change in that thing. So total cost, marginal cost would be the change in total cost divided by, well, what is the firm changing? How much they produce. So a change in that total cost divided by a change in the number of units I'm producing. Okay. So what I have ready to go, instead of working through that table, is a slightly different table with maybe the types of questions that we would see. So let me make sure this is getting published so that you can see this on the main page. Oh, I accidentally clicked on the packback assignment. So let's get both of those published. And then let's see if we refresh this. There we go. So we've got this kind of in-class quiz. I think I've got it set to be 8:30. I'm guessing we'll be done before then, but you need to kind of get this submitted before 8:30 this morning, right? So we'll work the next 25 minutes on it. Kind of take a look. Instead of showing you the answers. Oh, where's the preview option? I have to go to build. We'll kind of work through this together. Okay, so here we go, preview. So this is the same table for all of these questions, okay? So I'm going to start out here, and this is the information I was given. So I'm going to write this down so we have this on the dot cam, but I'll kind of talk through it. So there's a lot of missing information here. We're going to try to fill it all in, okay? So switch over the dot cam here, and I'll fill in the remaining stuff that we've got, okay? So I think I've got 45 here, 35. I'll even leave this out, even though I was given this, just to kind of think about building this out here. So 15, 5, 23.33 repeated, 20, 27.5, 25, 28, 2, 40, 50, 33.33 repeated, 31.66 repeated, okay? So we can start to think about how I can fill out this table, right? So maybe if this helps, we can kind of see here are all the costs associated with these different production levels. So I think the very first question says, what's the total variable cost of that 20th unit? Okay. So if I'm trying to find the total variable cost, right? We said the average of anything. So if I want to find the average variable costs, that's going to be my total variable cost divided by how much I'm producing. That's an average. You got to think about every single unit. Like let's say I had this data and I had the cost of every single unit. Well, how do I find the average of a set of numbers? If I've got 5 numbers, what do? I add them up and divide by 5, or how many numbers I had. That's all we're doing here. The total cost represents adding up the cost of every single unit. Well, then how many numbers would I have? How many units I have, right? So our total variable cost is like adding up the cost of every unit and then dividing by the total number of numbers I have, which was just the number of units I'm producing. So that's all we're doing with these averages. So if I, for example, I'm looking for the total variable cost of the 20th unit, I know that the average is 25. All I have here is a little bit of algebra to do, right? Multiply both sides by 20, and I get what? My total variable cost should be, oh, what? 500, if I'm doing math in my head correct here. Right. Any questions on this idea? So I think writing these equations out, kind of seeing the math is probably the easiest way to do this, right? But, you know, going from an average to a total or a total to an average, as long as we know the quantity, this shouldn't be too intensive algebra, okay? Any questions on this before we keep moving? We're going to keep building on it, so if you have questions, you should ask them now. Okay? So if I wanted to, and I don't have it here, but I could kind of write out what my total variable, my total fixed, my total costs are as separate columns. I think we can fill out the rest of this table without that, but if you wanted to, you could kind of think about, I could have a total variable cost column here, and I just found what? kind of think about it here. So I've got my total variable cost at the 20th unit we just found was 500. And you kind of build these columns out. So what are some other things I could fill in from this table just relatively quickly, right? So this is going to be any table I give you that maybe is missing parts, no matter what the question is. How could I fill out my average fixed cost column? So if my total costs are my total variable plus my total fixed, those are the only two types of costs we have. If I divide everything by Q here, what happens to the equality in that equation? If I divide both sides by the same number, does the equality change? If you guys want to be Kelly School of Business students, we need to know that if I divide both sides of the equation by the same number, what happens to the equality? It stays the same. Nothing changes. So what do these all now represent? Well, if I take the total cost divided by quantity, that's just my average total. Total variable cost over quantity, that's my average variable. And here I've got my average fixed. So if I know the average total and the average variable, what must my average fixed cost be? This is 45. This is 35 at a quantity of 10. What does the average fixed cost have to be? You guys are scaring me. This is difficult. We're going to have a real rough second exam. 35 plus what gets me 45? 10, right? I know it's early, but, you know, give me a little bit here. We'll get through this quicker. So I've got my average fixed cost of 10. Now, how could I fill out my average fixed cost column? Very quickly. So when I have a table like this, one thing I would do is try to figure out what my fixed costs are, and then I could fill out my average fixed cost column very quick. So if I think about this quantity of 10, my average fixed cost would be what? My total fixed cost divided by quantity. So if my average fixed cost is 10 at a quantity of 10, a little bit of algebra here, multiply both sides by 10. What does my total fixed cost have to be? 100. Well, now I can fill out this entire column, because how do I calculate my average fixed cost? I take the total fixed cost and I divide it by quantity. So 100 divided by 10 was 10. 100 divided by 20 is 5. 100 divided by 30 is what? 3.33 repeated. 100 divided by 4 is going to be 2.5. 100 divided by 6 is going to be what? 1.66 repeated. So finding that fixed cost, I can then fill out my average fixed cost column right away. And that's going to be helpful in finding some of the other missing values. Okay. Any questions on that idea before we keep moving? Okay. So the next question that we're asked, and I'll kind of go back to the screen here in a second, but since we're here, what are my total fixed costs at 60 units? Well, this is the idea that my fixed costs, I have to pay the same amount no matter how much I produce. So what did we just say our total fixed costs were at 10 units? Well, what was I doing at every quantity? I was still using the total fixed cost of 100, because my total fixed costs are always the same. Doesn't matter if I produce 10 units, 50, 100, 1,000, the total fixed cost will always be the same. Now, what's going to happen to my average fixed costs as I produce more and more? If I've got the same total, but I'm producing more units, my average is going to be going. So if I've got the same total, but I'm producing more, if my denominator is larger, what's happening to this fraction? It's going. So my average fixed cost should always be decreasing. So if I come up with these values for that average fixed cost column and they're ever not lower as I go down, I made a mistake. I made a math mistake somewhere, right? My average fixed costs have to be decreasing because I'm taking the same fixed cost and I'm just spreading it out over more units. Okay? It's kind of somewhat to the idea we'll eventually feel like this, scaling up my production, right? We have economies of scale. So, well, not quite, but that's close to the idea. So now that I have that, how can I find my average total costs at 20 and 30 units? My total costs are the sum of what? Two types of costs. Fixed and variable. So just average fixed plus average variable gives me my average total. Here, 26.66 repeated. Down here, 30. I've got everything except for one kind of point filled out now. Okay. So we've got our total fixed costs were 100. The next question, even though we filled in a bunch of this, we could have answered, we could answer the average total cost. Now that I have my averages, how would I find the total how would I find the total costs at 20 units? So if I want to find my total costs, all I have are averages. My average total cost is just my total cost over quantity. So if I want to look at, say, 20 units, my average total cost we just found is 30. What does my total cost have to be? It's just a little bit of algebra. I get my total costs would have been 600. So once I have my averages and my quantities, like you always have the quantities, I have to give you those. You can always back out what the total is, as long as you have the average. Any other questions on this before we fill in the very last one, which is the last question, I think, on that quiz? So how would I find my marginal costs, right? So marginal anything is the change in whatever we're looking at. So my marginal costs will be the change in my total costs. So here's also maybe a hint or a kind of thing you can use going into the exam. I'm never going to ask you to calculate marginal costs using anything other than total costs. I'm going to show you a way that you can, right? You might be able to think about why, but we'll walk through it with total costs and I'll show you one other way you could do it, but I'm never going to expect you to. So it's how much are my total costs changing by as I increase the number of units I'm producing. Okay. Now here, what are all my changes in quantity? Kind of kept this easy. It's always 10 to 20, 20 to 30, 30 to 40 is a change of 10, right? So when I'm looking at that marginal cost of the 40th unit, what was the change in my quantity? 10. Now I also need the change in my total cost. Well, I don't have total costs here, but how can I find them? So my average total cost at 30 units was what? 26.66 repeated. That should be equal to my total costs over the quantity of 30. A little bit of algebra, 30 times 30 here. My total cost would be at 30 units, 900. What about my average total cost at 40 units? Well, same kind of idea. What is my average total cost? 27.5. So what would my total cost be? Because remember, we need the change not in my average total cost, but we need the change in our total costs. Well, total costs over a quantity of 40, a little bit of algebra. I get my total costs are 40 times 27.5. So this would be what? 1,100 if I'm doing math in my head correct. Okay. So I've got my two total costs now. What was the change in my total cost? I went from, and if I'm doing math in my head incorrect, stop me, but 1,100 to 900. What was the change in quantity? 10. So this is going to be what? 200 over 10 or no, I did math wrong somewhere, didn't I? This is, where did I go wrong? Oh, I used the wrong number. Thank you. Sorry. This isn't 30. This is 26.66 repeated. So instead of 900, this should be what? 800. That makes a little more sense. Thank you. So 300 over 10, that should give me a marginal cost of 30. Okay. Now, why did I inherently know? So this is actually good that I made this mistake. So when I had that marginal cost calculated to be 20, why did I know that was wrong? What should be happening to my marginal costs? So depending on the numbers I give you, it won't always be that the marginal cost goes up by the same amount. In fact, notice here, initially my marginal costs were decreasing, right? And here they only increased by 5. Now from there on out, they went up by 10. It just so happened to be the same amount. But we said with our marginal costs, if I'm graphing out what these look like, they're going to look like kind of this Nike swoosh symbol, right? So this is part of what I went over in that video. Initially, why do my marginal costs decrease as I produce more? We've got gains from what? So let me know how many of you even bothered to watch that video. Gains from specialization, right? This is the idea that my workers are specializing their tasks, becoming more productive, lowering kind of my additional costs for every unit. Now, eventually over time, those gains from specialization are kind of exhausted. And now as I hire more workers, what am I doing? I'm hiring less and less efficient workers. So this is going to be where our diminishing returns to labor takes over. And we end up seeing increasing marginal costs. So once I saw the marginal costs start to increase, I knew that from every quantity there on up, my marginal cost should be higher, which is why I knew that it shouldn't be 20. It should be something that's higher than 20, something in between 20 and 40. Sure enough, we end up finding it's that value of 30 if I use that correct value of 26.66 repeat. Any questions on anything that I filled in there, or kind of anything since I scribbled out a little bit here, if anything's not quite clear or legible to you? Okay with this? Yeah. Yeah, I'll redo that since I used the wrong number. So if I wanted the total cost at 30, this is where maybe I should use a marker to make sure I'm staying on the same line. So if my average total cost at 30 units will be my total cost at 30 over this quantity. So my quantity is 30. The average total cost was 26.66 repeated. Multiply both sides by 30. And I get my total cost at 30 units would be 30 times 26.66 repeated, which was that value of 800. And then that's why when we're calculating our marginal costs, the change in the total cost going from 30 to 40 units, my total costs were going from 800 to 1100. Any other questions on that one before we keep moving here? Okay. All right, so we've got the marginal cost of the 40th unit was 30. What was the other one? We said the total fixed cost. I didn't have it written down here, but what did we end up determining? Do I have it somewhere? No. No, I know that I wrote it down. I think I put it in the back here. What did we say the total fixed costs were? So that was just where we know the average fixed cost is 10 at a quantity of 10. We can back out the total fixed cost must be 100, and there'll be 100 at every single unit, right? And you can actually prove this to yourself. So let's say I wanted to go down here and look at a quantity of 50. If I know that my quantity is now 50, my average fixed cost is now, 2. What would my total fixed cost be? A little bit of algebra, 2 times 50, sure enough, I get those same total fixed costs of 100. So it doesn't matter what quantity I use to find fixed costs, I always should be finding the same value. Any other questions on this before we keep moving? So I said that I'll expect you, when calculating marginal costs, to simply use the totals. I did want to show you what else could I use. So if I wanted to look at marginal costs, and that's the change in my total cost over a change in quantity. I just said fixed costs are going to be what for every production level? They're always going to be the same. So when I'm talking about the change in costs, will it ever come from my fixed costs? No, they're fixed. They're always the same. So what is driving my change in the total cost? The change in my variable costs. So what I actually could do, instead of using my total costs, I could use the total variable costs at those two quantities divided by the change in the quantity, which was 10. So how do I find my total variable costs? Well, that's once again, my average variable cost will be my total divided by quantity. So if I look here at 30, my average variable costs were 23.33 repeated, right? So if I do a little bit of algebra here, this is once again, check me if I say something wrong. I think this is 700, right? So the total variable cost at a quantity of 30 would be 700. What would my total variable cost be at 40? Well, at 40 units, my average variable cost is 25. So a little bit of algebra to get my total variable costs should be 1,000. Sure enough, what's the change in my total variable costs? 300 divided by that change in quantity of 10, we get the exact same value. So I can use my total costs, or technically I can use my total variable costs, because those are the only things changing. That's what's going to be driving that change in my cost or my marginal cost. My fixed costs are always the same. So that doesn't really help me out when calculating marginal costs. Yeah. Any questions on this side? I know I went through this a little bit quick here, but it's the same concept as what we did with total costs. We're just using the variable costs. Okay. All right. So still have 3 minutes. I don't need to see any emails. If anyone submits this late, it's not being accepted, right? This is the idea. If you're in class, you should have had this submitted even before now. We've covered all the answers, right? Total fixed costs were 100 at every single unit. We found our marginal cost. The 40th unit was 30. And I don't even remember with the first one, what was it? The total variable cost of the 20th unit, the kind of going back, we said that was what? 25 times 20, so 500, right? So we should have already kind of had all these answers in ready to submit, okay? The other questions before we go back to the slides here. So I can almost 100% guarantee you, you will have a table that looks something like this, or something like this that I will ask you to fill out. Well, here. Right? So here's another one where it might just be good practice, an additional example if you're looking for problems to work through. Try to figure out on your own how you could fill out this entire count, this entire table. You've got those answers to look at. Kind of start out with this, see what can I fill in. The best place to start is usually with your fixed costs, right? Then kind of start out on every line and think about, well, if I know my total variable costs and I know quantity, what can I definitely find? My average, right? So try to start line by line, thinking about what can I fill in, work through this line by line. Then once I do that, go back and see now, is there anything else line by line I can fill out? But the column that should always be kind of easy to fill out is once you determine what the fixed costs are, well, now I just need to take those fixed costs divided by every single quantity. I can fill out that entire average fixed cost column. All right. So once again, good practice here. Now this is an example where I have no what. So if I look at my marginal costs, they're always doing what as I increase production. As I increase quantity here, what's happening to my marginal costs? So I must have no gains from specialization, right? Only diminishing returns here. We won't waste time on that. We'll kind of talk through some of this, these ideas. So I want to kind of focus a little bit more on why these cost curves look like they do, and then we'll kind of progress to like thinking about short versus long run. So in that video, I kind of mentioned our average total and our average variable cost curves are always going to be kind of U-shaped. Right? So this is the idea that initially, as I increase production or increase quantity, my average total costs are going down. Now there gets to be a point where they bottom out or this average is minimized. And then if I continue to produce past that point, my average total costs start to then increase. Okay. So let's think about why here. Excuse me. So initially they'll be decreasing, eventually they start to increase. And the reason why is because we're going to have this idea that initially we've got gains from specialization. So as I produce more, I'm essentially spending less money per unit because my workers are becoming more and more efficient. Now, over time, those gains from specialization go away. I'm only on that diminishing labor portion. Now my workers are becoming more and more inefficient. So to get the same number of additional units, it's going to cost me now more additional money, or my per unit costs are going to be going up. Another way we can think about average total costs are my per unit costs. On average, what my per unit costs are. So if I'm a company, where do I probably want those per unit costs to be? At their highest point? If I'm making something, do I want the cost per unit to be really high? No. What do I want it to be? Guys, give me a little bit of something here. I know you're in the business school, so I know you have somewhat of a mind for this. If you're selling something and you're producing it, you want the cost per unit to be low, right? So what do? You go overseas and put your production facility over there, right? Why? Because you want those per unit costs to be as low as possible, right? Now, what is also, even if we don't have gains from specialization, what would be driving down my average total cost initially? So what's something that I said as you produce more is always decreasing? My average fixed costs. If my fixed costs are always the same, as I produce more units, what am I doing? I'm taking that same building lease amount that I have to pay, and I'm spreading it out across more units. So my average fixed costs are always going to be decreasing. So what's part of my average total? It's average variable plus average fixed. So the fact that my average fixed costs are decreasing and gains from specialization is what's going to be initially driving my average total cost to be going down. Now, eventually, we can kind of even think about, like in this example, the average fixed cost. Well, I should do the one that we were doing because it's a little bit more pronounced. So here, what's happening to my average fixed cost? First, they go down by 5, then 1.6, and what, 0.83. They start to go down by less and less, right? So initially, these average fixed costs, falling, is really going to drive my average total cost to go down. However, eventually, the average fixed cost, it isn't falling by much. So what happens to my average total? It starts to increase, right? This is this kind of U shape that we see to the average total cost, right? So that's what it's being driven by, okay? So with this in mind, right, we're going to be thinking about the efficient scale of production would be if we can get to this minimum point on our average total cost curve, okay? Now, what will end up being true is our marginal cost intersects that average total at its minimum point, right? You can kind of think about the reasoning as behind why. If I have a set of numbers and the current average is 10, right? If I add a number that's greater than 10 to that old set of numbers, what has to be true about my new average? So if I have two numbers, let's say 5 and 5, I add them together, the average is 5. If I add 10 to that, what's my new average? 5 plus 5 plus 10, so that's 20 divided by 3. So now I'm going to be at what? 6.66 repeated. It has to be higher. Anytime I add in a new number that's higher, it's going to pull my average up, right? This is the idea that that's what an average does. When you do better in certain grade categories, what happens to your old average? If you did better than what your grade was, it pulls your average up. So anytime the marginal cost is above my old average, my new average is going to be a little bit higher, right? Or increasing. Now, what if that marginal cost, the amount of cost that's being added in, is below my old average? Well, then my new average is going to be a little bit lower. So any quantity where my marginal cost is below the average total, my new average is going to be a little bit lower. The point where they'll intersect will end up being where the marginal cost intersects the average total cost at its minimum point. So that would be the idea. If I had an average of 10 and then the additional cost I added in was 10, what happens to my average? Stays the same. Right? Now that's like one singular point. So we often are going to be thinking about these ranges over here. And then, so I kind of already walked through this, right? Because the marginal cost is above the average, our new average is higher. Over here, the marginal cost was below the old average, so our new average has to be lower. This is going to be where our U shape comes from. Okay? So maybe like a shorthand way of remembering this, we kind of see these values starting from a quantity of 0. Let's say I had total fixed costs that were 10. Well, if I produce nothing, it's kind of weird. I really can't calculate an average, but it's kind of like my average is 10. So here, as I kind of increase my production, what's going to be happening to my average total costs? Well, initially, they're going down. And then at a certain point, if I produce past that, they start to go up. So where would the efficient scale be? What quantity would be the efficient scale in this example? So it's going to be where my per unit costs or my average total costs are at their lowest point, which would be at a quantity of what? 45, right? 0.55 is the lowest possible value that I see here. Now notice when my marginal cost is below the old average. So if I'm going from 20 to 35 units, what was my old average? 75. My marginal cost, or what I'm adding in, is now 0.33. That is below my old average. So what should be true about my new average? It should be lower, right? Sure enough, my new average, if I calculate this out, is a little bit lower. Now, what if we go from 35 to 45? My marginal cost of that 45th unit was slightly below the old average. So what happens to my new average? It's a little bit lower. Well, what if I go from 45 to 50? My marginal cost, what's getting added in is 1. Is that below my old average? No, it's actually above. So my new average should be a little bit higher. So this is kind of it's just simple math that's driving this relationship, right? If I add a number into a set of numbers that's higher than the old average, the new average has to be higher. If I add a number into a set of numbers that's below the old average, my new average has to be lower. Okay. And then we kind of talked about that minimum point, the efficient scale of production being where those average total costs are at their lowest point. Okay. So here's kind of our short run cost curve. So after this next exam, we'll use this a lot. Right? So this is why I kind of take some time, quite a bit of time to set this up. Here, our marginal cost is going to intersect the average total cost at its minimum. Our average total cost is going to have this U shape to it. Our average variable is also going to have this U shape. And I think I did this in the video here, but I'll kind of draw it out to really make this point. So here's my average total costs. Here's my marginal costs, intersecting them at their minimum point. When I'm thinking about my average variable costs, the same thing is going to be true, which is that my marginal costs, right? My variable costs were the only thing that was changing, right? My fixed costs were the same value. So my marginal costs are going to influence the average variable and my average total. So the way that they're impacting my average total is through my variable costs. So that same relationship is going to occur. If my marginal cost is below the old average variable, my new average variable is going to be a little bit lower. As soon as those marginal costs start to be above my average variable, what's happening to my new average variable? It's going to be a little bit higher. So that same relationship exists. Why is the gap in between my average total and average variable getting smaller and smaller? What is the difference between my average total and my average variable costs? My average fixeds. We said our average fixeds are the total fixed cost over quantity. So as I produce more, what's happening to my average fixed costs? They're going down. So the difference between my total and variable costs is getting closer and closer to 0, right? So that's why it starts out as a wider gap and gets more narrow towards the end there. Okay. Oops, sorry. All right. Any questions on that idea? Let me think. We might stay here for a second. Forget the order in which I have these things. Well, no, we'll kind of progress past this. Just to be complete, if I wanted to draw an average fixed cost curve in here, what would it look like? So it wouldn't be constant. That would be my total fixed costs. My total fixed cost would just be one value. What did we say is happening to my average fixed costs? It's always going down. So it looks something like this. You don't feel like you have to draw that in there. In fact, when we draw out these short run cost curves, a lot of the times we ignore the average fixed costs. It doesn't really have a lot of influence in our decision making, because one of the things that I talked about also in that video was the idea of sunk costs. Fixed costs in the short run are sunk costs, because no matter how much I produce, what's going to be true about my fixed costs? They're always the same. So should they be factored into my decision making about how much to produce? No, right? So we usually don't draw them in there because they just don't have any bearing on our decision making. With this idea of the short run cost curves and cost structure, we'll kind of move on to thinking about the long run. So in the short run, we said some things are fixed. Usually we think of this as like, our building facilities. Although like labor can be fixed. If like you think about sports teams and they sign contracts, they're locked into those contracts no matter what, unless they can trade the player or something. Like they sign it, they're locked into those costs, right? In the long run, everything is variable. So what is the long run? It's kind of hard to say, right? Like does everything become variable? Depends on the industry, right? Depends on exactly what those factors of production are. But we can say that once we can change everything, then we know we're in the long run. Okay? Everything is variable. Okay? So what happens to our cost structure? It becomes a little bit easier, because what's the only cost curve that we have? If my fixed costs are gone, average total will just simply be equal to. So average total costs are my average variable plus my average fixed. If fixed costs are 0, what are my average fixed costs? 0. So total cost would simply be my total variable costs, right? So here in the long run, we only have one average cost curve, right? My average total is my average variable costs. Okay. Questions on this idea before we keep moving here? Not crazy. So let's think about our movement between the short and the long run. So we said, if I'm choosing a production level, I want to be at the point where my per unit costs are at their lowest. Right? Now, once prices come into play, it gets a little bit different. But for now, we're just thinking about, if all I'm trying to do is minimize my costs, I want to be at the lowest possible point in that average total cost curve. Okay? So let's say I'm thinking about an example. And I've got all these things that are variable, but I have one thing that's fixed, which is the size of my production facility. So initially, maybe I start this business. We'll kind of call this my first average total cost curve, right? I start this business. I face these total costs. I want to continue to increase my production as long as these per unit costs are going down. Right? So I want to get to that minimum point here. Now, as time goes by, if I'm selling a lot of this product, what might I want to do? If I can, maybe now I've got, even more high quality workers available to me that want to come work for my company. I want to scale up my production, but I know if I stay in the same production facility, my costs are going to be really high, right? Because people are running into each other. Right? I only have so much machinery or things like that to like even move things from the dock bays, whatever. So what might I want to do? Move to a larger production facility that is more efficient. So just like when we were hiring and firing workers, we had like gains from specialization or diminishing. Maybe in moving these fixed factors, so like instead of labor, we think more about like moving to different sized buildings, I can actually lower my cost there as well. Maybe there's some efficiency in moving to a larger building once my production level gets to a certain amount. Right? So here, I can think about at any quantity, and here I'll call this, I think to line up with the slide, small. So this is my small production facility. Here's my medium production facility. Well, now notice, if my production levels are low, right? What's true about every quantity here? The average total cost in the small plant is below the average total cost in the medium plant. So which plant would I want to be in? My per unit costs at every quantity here, my average total cost is lower in this small plant. What plant do I want to be in? The small plant. Now, if I ever get to a point where I want to produce past this point, every quantity here, what is now true about my average total cost in the small plant relative to the medium-sized plant? They're now higher. So what plant do I want to move to? That medium-sized plant. I can reduce my per unit costs. And then I can kind of think about, I could continue to do that as I want to scale up my production. Maybe at some point, instead of this medium-sized plant, I'm thinking about, okay, there's this quantity that represents that past this point, if I want to increase my production even more, my per unit costs in the medium-sized plant are above the per unit cost in the large plant. So any quantity past this point, what plant do I want to be on or be in? The large plant. So we know that like anything here, we'll never see the firm choose to stay in that same size production. So over time, as they can change this fixed factor of production, the size of their production facility, what is going to be the average total cost curve? Well, initially, it's going to be that of the small plant. Past this quantity, they're then going to move to the medium-sized plant. Past this quantity, they're going to move to the large plant. Now, I chose 3 size plants here. Obviously, like you can choose between more than just 3. So what does this kind of start to look like? There's a little bit of like smoothness to it. But if I'm just thinking about the portions of these different cost curves that they're going to be on, it also kind of has this nice U shape. So our average total cost curve in the long run, it looks like the average total cost curve in the short run, but really moving to different portions on the long run average total cost curve, we'd be moving to different levels of that fixed factor of production. So in my example here, we'd be moving to different production facilities. Now it still has this U shape because the reason why we're moving to those larger production facilities because that's what's kind of lowering our per unit costs, right? But it's still going to have this kind of U shape to it. Okay. I don't know. I think the production facility size one makes the most sense, but you could think about this as anything that might be fixed that you can change in the long run. I know there's a lot going on. Any questions on this before we keep moving? So I've got another visual in the slides. Sometimes I think seeing it drawn out helps. Sometimes seeing it like this. So this was the idea that, oops, if I was at these lower quantities, we talked through the idea of, oh, well, the lowest per unit cost I can get would be in this small plant. Past this quantity, the lowest per unit costs, well, in my large plant, the average total costs are higher. So in this range, I'd want to be in the medium-sized plant to lower my per unit costs. And then any production past quantity B here, well, there my average total cost in the small and medium plants are higher. So I'd want to be in that large plant in order to kind of minimize those average total costs. So what does my long run average total cost curve look like? Kind of like the lowest possible average total cost across all those different size production facilities. All right. So in practice, there's more than 3, right? It's a bunch, I could choose all these different square foot production facilities. And so it's going to look a little bit more like this, right? But ultimately, what does the long run average total cost curve look like? Kind of has this nice U shape to it. Okay. Any questions on this before we keep moving? So this is I don't think this is anything crazy. So when we're moving, I keep using the production facility example, but it could be anything that's fixed. As initially I start to move to larger and larger production facilities, what's happening to my long run average total cost curve? It is decreasing. So there we would say that by increasing production, what am I doing to my per unit costs? They're going down. So I would say that is economies of scale. right? I'm scaling up production and I'm becoming more efficient in the sense that I'm lowering my per unit costs. So by moving to these larger and larger production facilities, initially, that's going to provide me with some economies of scale. I'm scaling up my production by moving to these larger facilities, and as a result, I'm lowering my per unit costs. Now, I drew this kind of big here. In practice, this is probably a small portion of the long run average total cost curve, but there could be a point where if I scale my production here, what's happening to my per unit costs? If that's flat, they are the same. So there, instead of economies of scale, whoops, there, it was already up there. We call this constant returns to scale, right? I'm increasing my production, my per unit costs really aren't changing. And then if I kind of continue to move, there eventually will be a point where if I increase my production even more, what am I doing to my per unit costs? I'm increasing them. So we wouldn't call this economies of scale. We would call this diseconomies of scale, right? By moving to larger and larger production facilities or changing this fixed factor production past this level, I'm actually increasing my per unit costs. Okay? So when economies of scale kick in and the average total cost curve, I don't know, I found this meme at one point, and it kind of goes along with this, okay? So the other thing that we're going to talk about, so we've got all these cost curves. We're now thinking about short versus long run. Like I said, this is going to have more implications for us after this exam. This is, I think, kind of setting a base, and hopefully the questions you'll see here will be a little easier. So the idea, like, if I'm looking at a long run average total cost curve, if increasing production decreases my long run average total cost, I've got economies of scale. We're just talking about costs in this module. Once we get to modules 10, 11, 12, and 13, we then start factoring not only costs, but also prices, right? And then it gets a little bit tricky. But for now, we're just looking at costs. So we're going to have 4 different types of markets. And I'm going to put them on a continuum here and just kind of talk through this. But the first, so this is like the remainder of the semester. But we'll talk about market concentration ratios before we dive into each one of these specifically. So you'll be expected to know what we're going to talk about here for the second midterm. So our ideal markets are what we call perfectly competitive. So this is that we have many, many, many buyers, many, many, many sellers of a product. What does that likely mean? If there's many sellers and many buyers, nobody has any market power. Because if you aren't willing to pay whatever price the company's charging, what are they going to do? Just try to go find someone that will. There's a lot of people that want to buy it. Well, what if you go to a company and you don't like the price they're selling? So think about like something where there's a lot of sellers. If I wanted, I don't know, let's say this morning I really had a craving for a Monster energy drink. I didn't get one, fortunately. But if I would have went to a gas station like, yeah, $6, I would have been like, there's plenty of other people selling it, and I know they'll sell it to me for less than $6, right? So I wouldn't buy it from them. So this is the idea that they can't get away with charging a jacked up price. Why? I'm just going to go to somebody else who's selling it. Maybe gasoline's a better example, but that was what's on my mind, right? So here, many buyers, many sellers. This is our perfectly competitive. A lot of competition. As we kind of progress, we start to think about there are markets where we have many, many. So these monopolistically competitive are going to be closely related to perfectly competitive. It's going to be we have many, many buyers. And we do have many sellers, but they don't quite sell the exact same product. So they've got a little bit, it's kind of like we have a small number of sellers. So think about like gasoline. Everybody's selling 87 unleaded gasoline. It's regulated by the government. It's the exact same product. But let's think about if I want to buy something that there's a lot of, but it's kind of unique. So let's say, oh, I don't know. You can even think about the market for like fast food. There are many sellers of fast food, right? However, every type of fast food is a little bit different. Even if you just focus in on like hamburgers, there's people, like my grandma would have sworn up and down that the Wendy's hamburger is the only good hamburger out there in terms of fast food, right? So for her, how many sellers are there for fast food hamburgers? One, right? Because they've differentiated their product enough to where for some consumers, they don't even consider the other ones, right? So it is kind of like a perfectly competitive market, but firms have been able to kind of differentiate their product enough to where they have some market power. So what do you think that likely means about the price they can get away with charging? Higher. Yep. So as we progress, we're going to think about these firms start to get more and more market power. They likely can charge consumers a higher price. So oligopoly, this is going to be one where we have many buyers, but a small number of firms. So this might be something like, if you think about like personal computers, there's only a couple major players, right? There's only a couple major companies who are selling like, well, I guess if I buy mine from the university, there's only like 2 companies that they even buy from, right? So there's a very small number of buyers in that market, so they can get away with charging a slightly higher price. If I then kind of keep progressing the game that we've probably all played or heard of at one point, monopolies, whereas I have many buyers, but I only have one seller. If I want electricity in Bloomington, there's one provider of electricity, right? They have a local regional monopoly, and there's one seller. So what do you think they can get away with doing? Charging high prices. So generally, if we want things to be efficient, we actually want to be closer to the left-hand side of this continuum than the right-hand side. And we'll talk through more of that kind of after the next exam. But for now, just knowing those different types of markets exist. So in order to identify what type of market we're looking at, we're going to use 2 different measures. The first is the 4-firm concentration ratio. These questions, in my opinion, should be hopefully easier ones on the midterm. And I can guarantee you'll have questions about this. Okay. So all the 4-firm concentration ratio does is adds up the percent of the total market share of the top 4 firms. So if you can look at it as a set of numbers, you can identify the top 4 numbers in that set of numbers and add them up. You can calculate the 4-firm concentration ratio, right? So, well, here, I guess I jumped the gun. What would a 4-firm concentration ratio of a monopoly look like? Well, what market share? There's only one firm. What's their market share? 100%. What if I had like oligopoly markets where there's only 2 or 3 firms? My 4-firm concentration ratio would be, so if I'm adding up the market share of the top 4 firms, if I only have 2 or 3 firms, what would their market shares add up to? 100%. So it's not a perfect measure. It's hard to differentiate between, say, monopolies and oligopolies if I'm just looking at this 4-firm concentration ratio. Now, what would a 4-firm concentration ratio of like a perfectly competitive market look like? If it was truly perfectly competitive, let's say I've got thousands of sellers, right? So maybe this is something like, I'm starting to think there's markets that are getting close to this. Like even though they do it through a company, anytime you have a platform where you can like Facebook Marketplace, there's tons of sellers, right? And there's millions potentially, right? So what would the 4-firm concentration ratio be of a perfectly competitive market? Pretty close to 0. Now, will it ever truly be 0? Even in markets that are really competitive, we think about things like the market for gasoline, right? There's many sellers on every corner. There's tons of different companies. The concentration ratios might still be relative, 4 or 5, you can even see 10%, and it can still be a perfectly competitive market. But the idea is it's going to be closer to 0. Okay. Right. So closer to 0 or 1%, kind of thinking about if we really had this example where it was like hundreds of sellers. So if I gave you sales numbers, how would I find the 4-firm concentration ratio? Well, how do I find the market share of a firm? This is going to be their sales divided by what? Total sales in the market. Now, if I do that, I don't have a percentage. I've actually got the proportion of sales. So if I took each firm's sales here, divided it by the total, what do I still need to do? Multiply it by, how do I move from decimals to percentages? Multiply by 100. So here, if I've got all the other firms, I've got the top 4 firms, what could I do? Well, the total would just be adding up all of these sales. I would then add up the sales of the top 4 firms, divide that by the total, and then we said we still have one more step. That would be kind of the proportion of sales. I actually didn't throw it in here. What would I need to do? I didn't complete my formula. I would need to multiply it by 100 to turn it into a percentage. Now I could do this like individually, figure out the percent of each firm and then add them up, or I can kind of add the sales up of the top 4 firms and then convert it into a percentage, right? Either way, it should give me the same answer. questions on this side? This one, once again, this shouldn't be bad looking at a table like this. Or maybe I even simplify it for you and I do something like this. What would the 4-firm concentration ratio be of phone? So this is a little bit older data. I think I got this from 22 or 2023. But what's the top 4 firms market share here? Well, if all other firms in the industry are only having 1.1%, what's the top 4 firms market share? 99.99%, right? Or if I add these up, I get the market share of these top 4 operating systems for phones is 99.9%. So what is the phone operating system market pretty close to? Probably wouldn't call it a monopoly. There's not one firm, but there's only a small number. So we would probably call it an oligopoly. There's a few small, there's only a few firms in this industry. So just to kind of grab some just to think about different markets as we start to think more about firms specifically in the kind of latter half of this class. Kind of make some points like video game consoles. This is a weird one, but tennis balls is like there's the top 4 firms. It's literally there aren't more than 4. So the market shares are 100% of the top 4 firms. If you look at things like credit cards, even there's only like a few major kind of companies. They're all kind of owned by the same parent company. So it's pretty close to 100% for the top 4 firms. And then you can think about things we kind of start to get lower and lower, things like that beer and automobiles here. They're still heavily concentrated, but not quite as much as some of these other ones, right? So in general, a lower 4-firm concentration ratio means that there's actually going to be more what? More what? Competition. Yep. We think about a lower ratio means there's more competition, higher ratio, less. So we kind of have a problem with this 4-firm concentration ratio. We already kind of mentioned. For a monopoly or for these oligopolies, the 4-firm concentration ratio might look no different. Might look like it's 100%. But we know that those markets are inherently different. Okay? And in fact, what about 2 different markets? Let's say I had a market where the top 4 firms, each firm had 20%. So I have a 4-firm concentration ratio of 80%. And I have another market where the top firm has 77%, and the next 3 all have 1. Well, I still have the same kind of 80% 4-firm concentration ratio, but those are 2 very different markets, right? So I'll kind of use a small set of number example to kind of show you how this secondary measure is maybe a little bit better, right? So when we're calculating our HHI, or our Herfindahl-Hirschman index, we're going to take the market share from each firm squared and add that up to whatever the last firm is. Okay. So let's think about a couple of examples. So if I have a monopoly, what would my HHI measure be? Well, what's the market share? How many firms do I have in a monopoly market? 1. What's their market share? 100. So 100 squared would be 10,000. This is the highest HHI I could ever see, right? So monopolist, the highest Herfindahl-Hirschman index I could ever see is 10,000. Okay? Now, as I kind of progress down here, what if I had a perfectly competitive market? So if it was perfectly competitive, this gets kind of weird to think about. We can use a really small number. What would the market share of each firm be? Really close to 0. So let's even just use 1% just to kind of have that example. Well, 1 squared plus 1 squared plus 1 squared, right? I would kind of keep adding these up. If I had 100 firms, and let's say they all have 1% of the overall market share, I'd end up with an HHI of 100, right? Now, the more firms there are, the smaller the market share they have. That's going to get closer and closer and closer to 0. But even with 100 firms, each sharing the market equally, we'd have an HHI that's relatively low. So even 100 would be relatively low, right? Monopoly, 10,000, we can kind of think about in between. These would be markets that are somewhere in between perfectly competitive and a monopoly market. So why do we maybe like this HHI measure? So let's think about something. So we'll call this market 2. Let's say I have 2 firms and they're sharing the market equally. What would my HHI be for that market? So if they're sharing it evenly, there's 2 firms. What's the market share of each firm? 50%. So what? 50 squared is what? 2,500. So this should be 5,000 if I'm doing math in my head correct, right? So notice, even when we have just a second firm and they're sharing even, what happens? My HHI is cut in half, right? So the HHI, when we square market shares, it really over penalizes when we have firms that have a really large amount of the overall market share. In fact, we could have kind of maybe to see this, let's say I have 2 firms, but I have 1 firm that has 90% of the overall market share. So there I would have 90 squared plus the other firm would only have 10. So this is going to be what? 8,100 plus 100. So if I'm doing math in my head, correct. Well, notice here, this is why the HHI can be valuable. Because these top 3 markets that I'm looking at would all have 4 firm concentration ratios of what? All of them have less than 4 firms, so they would have to have a 4 firm concentration ratio of 100%. But the HHI allows me to identify, well, yeah, but one of those markets, there's only 1 firm owning all of that market share. And even when there's 2 firms, I can differentiate between a market where those 2 firms are evenly splitting it, where the HHI measures only 5,000, or a market where 1 firm is like the predominant firm, right? 90% of the overall market share. I can see that difference in my HHI measure. So not only will the number of firms kind of influence my HHI here, it's going to allow me to identify, is there like an even spread across all these firms, right? Even when there's 2 firms, 2 different markets, both have 2 firms, I can identify what's less competitive by if it has a higher HHI. So this one, hopefully you can kind of much less competitive, right? 1 firm has 90% of the overall market share. The other one, they were evenly splitting it, okay? Any questions on this idea? Okay, let me see. I might not go back to, I don't know what else I have here. I think we should be getting close to the end. Yeah, so I've got something else I want to do here. We did a lot of these HHI examples just to kind of, I don't know, I always like to try to push people's thinking. So let's say I had my example of like Facebook Marketplace. And this is a theoretical example. We can never truly have this many. A perfectly competitive market, not only would I have many sellers, I would have an infinite number of sellers. So let's say I had a perfectly competitive market, what would the market share of each firm be? So if I have an infinite number of firms, let's say they're all splitting it evenly, everyone's market share would be 1 over infinity, right? So if I'm calculating like an HHI, the market share, and I can think about times 100, right, would be here. I'd square it, and then I'd do that for every firm that I had. Well, what is 1 over infinity? In the limit, it is 0. 0 times anything is 0 squared is. So what would my HHI be for a perfectly competitive market? 0, right? Now, can we ever truly have an infinite number of firms? No, right? But we can progress towards that. Once again, I probably won't push you as far here. Or just kind of knowing the continuum of this HHI, it's somewhere between 0 and 10,000. A perfectly competitive market, which we'll never see in practice, HHI of 0. A monopoly market, which we can sometimes see in practice, 10,000. Okay. And then to kind of end this out, I know you're probably all itching to get out of here, but I've got kind of a couple you can kind of look through, video game consoles, operating systems, beer manufacturers. You can start to think about automakers. We start to have different measures, kind of this HHI and market share. And that's going to allow us to identify the type of market we're looking at. And then after the next exam, we're going to analyze each one of these different 4 types of markets a little bit more intensely. Okay? So before you get out of here, try to do you a favor. What do you need to make sure you have done before Friday? At the end of the day, tomorrow. Get that pack back out of the way before you leave. There's still a quiz due the Monday after we return from spring break. So I think that's the 24th, if I'm remembering dates correctly. The CL sessions are on tonight at 2 of the locations. You can find out which 2 in that announcement on Canvas. And then that Sunday we return from spring break, the same kind of applies to that Sunday. There will be none this Sunday. Okay. Other than that, I will occasionally look at my email over spring break, but I probably won't be glued to it. But feel free to email me and I'll kind of get back to you as quick as I possibly can over then. Otherwise, a fun, safe spring break, and I will see you guys in about a week.
Testing Tuesday, right?
Thursday.